This is video number 5 for sections 8.3 and 8.4, Simplifying Complex Fractions, Method 2. So take a look at this example problem. It is once again a complex fraction, one large fraction with a bunch of little fractions inside. I could use method 1 on this problem, the one from the last video. It would just take a long time because the first thing I would have to do is I would have to get a single little fraction up top. Well, that means I'd have to add these two little fractions, which means I'd have to get a common denominator, I'd have to change over to that denominator, and then I'd have to add. Then I'd have to get a single little fraction down here on the bottom. So I'd have to carry out this subtraction problem by finding a different common denominator and changing over and subtracting. And when I was done with all that, then I would do that division step. It's just a lot of work. And so in problems like this, method 2 is just a lot faster and a lot shorter of a method. Let me remind you of how method 2 works, and I've got the list of steps over here on the side for you. Remember, method 2 is the one where you concentrate on wiping out all the little fractions at once. You begin by finding the LCD of all the little fractions. There are 4 little fractions in this case, which means there's 4 little denominators. I've got x, I've got x times x, I've got x, and I've got x times x times x. I'm saying it that way because I really need to concentrate on factors in order to find the LCD. I'm thinking of the grocery store approach. The nice thing here is there's only one type of factor. There's x's, right? It's like I have 4 grocery lists. This one says buy 1x. This one says buy 2x's. This one says buy 1x. This one says buy 3x's. Well, remember, the pickiest list is the one you go with. I'm going to have to take x cubed to satisfy this picky list. The other ones, 3 is plenty to satisfy them. Okay, once I have the LCD, then I take that and I go to the big fraction and I multiply the entire top by that LCD, by the x cubed, and I multiply the entire denominator by the x cubed. In terms of actually writing it out, let's think about what's going to happen here. You're going to have to distribute this into all of these pieces. So the x cubed is going to get distributed here, here, and then on the bottom here and here. 4 different places. I would highly suggest that instead of writing it the way I just wrote it here, that you write it instead in this way. Let me copy down the original problem. I need to multiply each of these little fractions by x cubed. How do you multiply a fraction times a whole number, so to speak? You put the whole number over 1. What I would very much suggest that you do is go next to each of these little guys and write times x cubed over 1. This allows you to physically do your cross-canceling without having to keep too many things in your head, and I think it's definitely the best way to have success with these problems. You now have 4 little multiplications to work out, and if we do it correctly, all the little denominators are about to turn to 1s. That's the whole point of method 2. Okay, take this first guy. What cross-canceling do I have? Well, I have a common factor of x, top to bottom. That will get rid of one of these x's, leaving me with just a couple of them. And that will get rid of this x, leaving me with, of course, that 1 when I divide it out. In the second guy, I have 2 x's now in common, so I can get rid of both of those, leaving me with 1 up top. Third multiplication problem, again, 1x here gets rid of 1 of those x's, leaving me with 2. And then the final one is the simplest one. I have 3 x's on the bottom and 3 x's on top, so those all go out. If you look carefully at all the little denominators, they're all 1s, which means we don't have little fractions anymore. I'm ready to finish this thing off. the result of my first multiplication problem, just multiply across the top. The bottom doesn't really exist anymore. It's just a 1. That's going to be 3x squared. The next one would be 2 times x, which is 2x. On the bottom, let's see, I think the only thing left here is an x squared. Everybody else is just a 1, and the final one appears to just be a 4. That's pretty speedy. In one giant step here, I rid myself of all of those little denominators. I don't have a complex fraction anymore. I have a nice simple fraction. Method 2 is very streamlined. Am I finished? Well, maybe, maybe not, because remember, at the end of any of these problems, you always have to check to see if you can reduce your final fraction. How do you tell that? You can't tell until you are looking at factors. So your next job is to factor the top and factor the bottom. On the top, I believe I've got a GCF of x that I can pull out, leaving me with 3x plus 2. Bottom, there is no GCF, but it is a difference of squares. It's going to factor in that a plus b, a minus b pattern. Okay, now that everyone is factored, I can look to see if any of those factors match top to bottom, and of course they don't. I have 4 distinct factors here, which means this is my final answer. Remember, we like to have our answer in factored form so that it's obvious to everyone that it has been reduced. I'll work another example problem here in a second, but before I do that, let's go back up to that problem from the last video where we used method 1. We could have used method 2 on this problem. Now, I think method 1 was great, and that's what I would do if I was doing the homework, but we could have used method 2. Method 2 would be go to the little denominators and find the LCD of those little denominators and then multiply the big top and bottom by that item. Well, what would the LCD be? Let's see. In terms of the numbers, clearly the only number is a 4, so I definitely have to have a 4 to satisfy this little denominator. What about x's? Well, it's the pickiest one that I have to satisfy. This guy only needs 1x, but this guy needs 2 x's, so I'd have to take both of those in order to satisfy this denominator. My LCD would be 4x squared. What do I do with that? I go then to the big top and bottom, and I multiply each part by that LCD. I'm going ahead and writing it over 1 because I know that that's what's coming. And then you would carry out these multiplications and simplify. I'll go ahead and leave it to you to do that. And obviously when you finish, you should have this same answer that we got before. Let's go ahead though and move down to a fresh example. So take a look at this one. It's another complex fraction with a bunch of little fractions inside a big fraction. I'm trying to clean it up. Method 1 would truly be horrible with this one. You'd have to carry out this subtraction problem here, then you'd have to carry out this subtraction problem here, then you'd have to divide. It would take a long time and be very messy. Method 2 is really going to be the better way to go, so let's demonstrate that. I look at all the little fractions. There are 3 little fractions this time, and I find the LCD of those little fractions, which means I really need to make sure I'm looking at the factored form of these denominators. The nice thing is none of them factor. They're already in factored form. And so I just need to do my usual grocery list thing. How many types of factors are there? Only 2 types, just x minus 1s and x plus 1s. How many do I need to take? Well, nobody needs more than 1 of anything. So if I just take 1 of each, every single list is satisfied. The tempting one might be to take 2 of the x plus 1s, but this guy doesn't need 2x plus 1s, this guy doesn't need 2x plus 1s, this guy doesn't need any x plus 1s. 1 is plenty to satisfy every single list. Now that you've found the LCD, method 2 says you go to the big fraction. I kind of like darkening that in to remind myself I'm now going to the big fraction. I'm going to take this entire numerator and times it by this LCD, x minus 1, x plus 1. And then I'm going to take this entire denominator and times by the LCD, x minus 1, x plus 1. Just like the last problem, this means I'm going to have to distribute this thing in 2 places up on the top and 2 places down here on the bottom, which means in terms of writing it, I would suggest you do the following. Let me go ahead and recopy the original problem. You know that you need that LCD multiplied by each of these 4 little pieces here. And I tell you, it's just so easy to make a mistake unless you physically write it out all 4 times. This guy over 1, and then I'm going to do it again over here. My LCD, I'm putting the over 1 because that's how you multiply a whole number times a fraction. This guy, I guess I don't need to put it over 1 because I don't have a fraction, so I'll just write it here next to the 4. Here's another little fraction though. Every part of the big numerator and every part of the big denominator needs to be multiplied by that LCD. So that's 4 multiplications in all. Okay, how do we multiply fractions? Well, we start off by seeing if we can do any cross-canceling. We definitely can here. Remember, all of the little denominators are about to be equal to 1. It's pretty simple. In the first guy, it's the x plus 1s that drop out. In the second one, it's the x minus 1s that drop out. In the third one, nobody drops out. I don't have any fractions there. And in the fourth one, it's the x plus 1s that drop out. If you look across the board, there are no little denominators anymore, which means we've just wiped out the complex fraction. Now, since this example is a little bit more complicated than the last one, let's go ahead and just write down now where we're at. So from this first multiplication, I have a 3 being multiplied by an x minus 1. I'll work it out in just a second. The next one, I have a minus 2 times an x plus 1. The bottom is perhaps the most complicated. Let me go ahead and do this FOIL problem. It's actually an easy FOIL problem because the middle parts cancel out. I'm just going to end up with x squared for x times x. The plus 1x and the minus 1x go away, and I get minus 1 at the end. That's being multiplied by 4. And then the last part, let's see, I have a minus 24 times an x minus 1. Okay, I've just written it out because I don't want to make any mistakes. Now, don't do any strange things like look for things to cancel. These are not factored. These are giant subtraction problems, not giant multiplication problems. So I need to actually work all this stuff out by distributing. The top becomes 3x minus 3, and then minus 2x minus 2. Just distributing here, the bottom 4x squared minus 4 when I distribute the 4 in, and minus 24x plus 24. Then I've got some like terms. Let's see, 3x minus 2x is x, and then minus 5 up top. And then on the bottom, what do I have? I have 4x squared, and then minus 24x, and plus 20. Am I finished? Well, maybe, maybe not. I don't know if I'm finished until I check to see if I can do some reducing. I can't do any reducing until I'm looking at factors. So let's go ahead and factor the top and the bottom. I don't believe the top factors. The bottom, I believe there's a GCF of 4, so let's pull that out. And then the bottom part keeps going. It's a trinomial. The numbers look pretty small. I think I can do reverse FOIL. I mean, it's got to be x and x here. The only way to make 5 would be 5 and 1. And the only way to make that minus 6x in the middle would be to use two negatives. Negative 5x and negative 1x makes negative 6x. Well, you can see, remember we tried to factor this but couldn't, you can see that I do have a common factor on the top and on the bottom, x minus 5. Remember, when you divide these things out, you're left with ones. Sometimes that's not important, but here it certainly is, to remind yourself that you end up with a 1 on the top. The final answer to the problem then looks like 1 over 4 times x minus 1.